Hello all, welcome to my channel. So today I would be covering topics related to electric dipole and electric dipole moment. So let's start with this topic. You should know first of all what electric dipole is. So it is a system of two equal and opposite charges separated by a certain distance. So that means if we are talking about electric dipole, we should have two charges which are equal but opposite in sign. Opposite charges should be there. And then they should be separated by a distance. If they are not separated by a distance, then they can't be considered as an electric dipole. So three things are there. One is they should be equal, charges should be equal. Second is the charges should be of opposite sign. And then we have third thing, that is they should be separated by some distance. So in this case it is 2a. So in this case AB is actually the length of the dipole, that is 2a. It is written as 2a vector. Then AB you can write is length of a dipole. AB is length of the dipole which we need to measure using anything if we are given with actually plus q and minus q. Now the next thing is electric dipole moment. Now that is the measurable quantity and we have to study about that only in this case. So let's start with electric dipole moment. Electric dipole moment is actually the product of charge and the length of electric dipole. So it is actually applied on electric dipole. So the formula for this is P vector equals Q into twice of A, that is length of the dipole. So in this case, SI unit of electric dipole moment will be, for Q as you know it is coulomb, and for A we have meter. Now moving on to electric field on axial line of an electric dipole. So we would be considering electric field of an electric dipole on an axial line. Axial line means the line should be a straight line and we have electric dipole on it. So let's draw it here. So I would be applying on axial line. So we have two dipoles. Sorry, we have one dipole. We have negative q. We have positive q. They are separated by a distance of 2a. Now suppose we have a point in middle that is separated by a and a with respect to minus q and plus q. Now the direction for I will take the first one as A and the second one as B. So applying the electric field on it. So the direction for electric field for A will be in this direction as it is a negative one. For B it will be radially outward. So EB here in this direction. And the total one will be in EB direction. Now we will apply the electric field on this. So the resultant electric field PE, which is equal to EA plus EB. So first of all we need to find EA. So magnitude of EA will be 1/4 pi epsilon naught Q AP square. P is here in the middle of EA and EB. So we would be taking any point at point P. We would be applying electric field at point P due to dipole will be the resultant of electric field EA and EB respectively. So AP square. Now AP square will be, I will be taking this distance from O to P as R. So it will be 1/4 pi epsilon naught Q. AP in this case is AP, A starts from here, so it is A, then we have R. So it will be A plus R whole square, or you can write R plus A whole square. This is along PA. Now for EB, it will be again 1 over 4 pi epsilon naught q. EB is till part here, so it will be BP square equal 1 over 4 pi epsilon naught Q. So in this case, if we need to find the value for BP, it will be R take away minus A, that is removing OB from here. So it will be R minus A whole square. It is along PX. Now, as you can see, we have to find EA plus EB. Now, in this case, we can see that EB is actually greater than EA. The mod of EB is greater than EA. And you can see since EA and EB act along the same line, but in opposite direction. They are in opposite direction. Therefore, we have to take EA negative. So, if in the vector form. So, it will be E vector form. Then as you know EB is greater, so I will take it first. Then negative of EA as it is in opposite direction. So it will be vector E equals 1 4 pi epsilon naught Q over R minus A whole square minus 1 over 4 pi epsilon naught Q over R plus A square. Now taking common whatever we can take q and 4 pi epsilon naught common. Then we have r minus a whole square. Then we have r plus a whole square in the bracket. Then we can solve this part using cross multiplication. So it will be r plus a whole square minus r minus a whole square over r minus a whole square, then r plus a square. So let's solve this further. Q 4 pi epsilon naught, then r plus a whole square. It will be r square plus a square plus 2ra minus of r square plus a square minus 2ra over r square minus a square whole square in the bracket, close bracket. We have q 4 pi epsilon naught. So this r and this r will get cancelled. This r, a with a square will get cancelled with this a square. Then we are left with 2ra plus 2ra. It will be 4ra r square minus a square whole square in the bracket. Then now, as you know, we have P equals Q of twice A because of electric dipole moment. Now in this case we have Q. We can write 4 as 2 into 2. So we have 2A as well. So we can reduce this form into P. So it will be 1 over 4 pi epsilon naught. Q and 2A will be depleted here. So we are left with 2P in vector form, then R, then we have R square minus A square whole square. So this is actually the electric field in vector form. Or you can write, if I say that my dipole is of very small length, then that means A is negligible. A is very less than R. So it is negligible. That means we can reduce this form to, this can be 0. This will go to 0. So it will be 1 4 pi epsilon naught in bracket. We have 2p. We have r here. Then at the bottom we have r4 because we have 2 here. So it will be r4, or you can write it as 1 over 4 pi epsilon naught 2p r cube. So this is when dipole is of very small length. So this is a special condition one. It should be applied when we have a very small dipole and as compared to R basically. So that's your answer for electric field on axial line of an electric dipole. So that's all for this video. Thank you for watching this video.